Now we'll get into the in-depth analysis about line chart, which is also an example. So first of all, I'll create a file like the way I created for bar charts as linechart.py. After this, I'll import my matplotlib library, which is useful for plotting the graphs. Matplotlib import. Now I'll say pyplot as plt. So this part has been done. After this, I'll create a variable named variance. So variance is nothing but the variance, or we can say the variable output to be delivered. So that will be an array of random numbers, say 1, 2, 4, 8, 16, and then we have 32. After that comes 64, then comes 128, then after that comes 256, and so on. So after this comes the next scenario for the next variable, which is bias squared. So that I'll say bias underscore squared equals 256, 128, 64, and then 32. After that 16, and then comes 8, and after that comes 4, then 2, then 1. Okay, so this section has been done. Now comes with the total error section. So it is total underscore error, which is equal to x plus y for x comma y in zip. So we'll calculate it with respect to zip of variance comma bias squared. And then we'll calculate the excess value as I for I, and then I'll say underscore in enumerate the value as variance. So we are actually enumerating, or we can say taking the bias squared value and variance value and enumerating. Enumerating means creating a key value pair with excess. This would be my x-axis. Now after this, the next scenario is we need to plot the line chart. So it will be done as plt.plot, and I'll take it with the x's value as x-axis, variance as my y-axis, specifying the color. So color code is given. For green it is small g, and the label which I want to specify is, the label will be based on the y-axis. So my label will be variance. In the similar way, I'll do for the other things, that is the bias squared and total error, which is calculated. So I'll say plt.plot x's comma bias squared, and the color I would like to specify is red, and after that comes the label, which is bias raised to 2. Now after bias squared comes total error. So my total error will be depicted with the blue color. So it will be plt.plot x's comma total underscore error, and the next thing comes, it will be the color blue. After that comes is the label, which is equal to total error. Then comes the legend. So my legend will be calculated in this format as plt.legend with a value of 9, and the x label will be, that is the x-axis label. So we will specify the x-axis label as model complexity, and the y-axis label, that is plt. So y-axis label is already been specified that it will be based on variance, bias squared, or total error. So that will be specified in this label. So we will not keep anything like specification with respect to y-axis. After that comes is the title. So my title will be nothing but the bias variance trade-off. So that will be mentioned over here. The bias variance trade-off, and after that comes is the necessity for showing up the plot. So that is plt.show. So in this way, I have created my particular line chart. The only thing I have not mentioned anything called as bar. So I have mentioned the legend and the plotting with the various values depicted, which means that there are 3 lines which needs to be depicted with respect to the y-axis and so on. So now let's go to the command prompt. So this is my command prompt. So the important thing now is to run my line chart. So I'll say Python line chart.py. So we get the bias variance trade-off. So very well depicted with the blue color as the total error. Red color represents the bias raised to 2. Variance is depicted with the green color. And the x-axis is the model complexity. And y-axis is depicting whatever the values which we have over here, or which are the legends. So this was the basic example when it came to line charts. Next chapter, we'll understand about the scattered charts, or we can say scattered plotting type of structure. So let's get started with the next chapter.